Hello everyone, my name is Terry, and today I am going to be going over a practice test that I put together for my survey of calculus class in their integral chapter. There's 30 questions in total, and at some point I should be putting the questions on my website and the times at which each question occur throughout this video. In either a description or a body paragraph on my website. So you can skip around the proper questions. Anyway, I can already tell this is going to be a very long video, so let's get started. Let's start with number one. The directions read, find the indefinite integral. So we've got the integral of dx. As we know, the integral and the derivative are opposites of one another. Now this isn't exactly how it should go, but this is kind of what I do. I just circle the integral and the derivative, and they kind of go away. They cancel, because we know that they're the opposite. And what I'm left with is x. So I've got x, and then I've got to put my constant, so plus c. And even if you got to that answer through some sort of delusion like I did, you've still got the right answer. Let's try another one. Let's try 2. We've got the integral of du. Alright, following the same exact logic, we're just going to wrap our integral and our derivative together, because that's what that d stands for, derivative, or delta. They cancel, and we're left with u, and then we're going to add our constant, plus c. Wonderful. Let's try number 3. We've got the integral of 7x. Am I adding my, yes, I am, dx. Making sure I was putting my dx's in the other ones, but that's all there was. This is going to be our general power rule, or just the power rule, really. We're going to add 1 to our exponent, and we're going to divide by that exponent, 1 plus 1. So that equals 7, 1 plus 1 is 2, 7 divided by 2, x squared, and then we're done integrating. So then we can say plus e, and we're done. Wonderful. Let's try 4. 4, we've got the integral of 1 over the square root of x dx. Well, we're going to rewrite the square root of x as x to the 1/2 power. So we've got the integral of 1 over x to the 1/2 power dx. And then we're going to pull up our x to the numerator. So we wind up with the integral of x to the negative 1/2 power dx. We can take the integral by adding 1 and then dividing by that number, negative 1/2 plus 1. And that equals, well, negative 1/2 plus 1 is positive 1/2. So we've got x to the positive 1/2 divided by the positive 1/2. And when you divide by 1/2, that's the same as multiplying by 2. So we've got, we're going to multiply by 2, x to the 1/2. We're going to say plus c, and that should suffice. Or we could, of course, write it as a radical, square roots of x plus c. That's actually probably a better answer. Okay, number 5. We've got the integral of 6 over x squared times the square root of x dx. The first thing that I'm going to do is I'm going to factor out my 6, because I can use my constant multiple rule, saying that any constant multiple, 6 is a multiple because it's multiplying, I can factor it out of the integrand. So I'm going to do that. So I wind up with 6 integral of 1 over x squared, square roots of x dx. My next step is to multiply the x squared and the square root of x. As we covered before, last example actually, the square root of x is the same as x to the 1/2 power. So we've got 6 integral 1 over x squared times x to the 1/2 power dx, which we would wind up adding our exponents because we're multiplying the bases. So we wind up with 6 integral 1 over x to the 5/2 dx when you add your exponents. A lot of algebra going on so far, just before the integration. And we're not even at the integration yet. So let's pull up our x to the numerator. So we've got 6 integral x to the negative 5/2 power dx. Doing our power rule, we add 1, and that gives us, well, let's put a 6. We're going to use a bracket to isolate that to signify that it is a multiple, so we need to multiply by it later. Negative 5 over 2 plus 1 is x to the negative 3 over 2, and we're going to divide by that. So divide by negative 3 over 2 plus c, and when we are dividing by negative 3 over 2, that's the same as multiplying. That's the same as multiplying by 2 over negative 3. So I've got 6 times 2 over negative 3 x. Let's actually get rid of that negative exponent now. So we've got times 1 over x to the 3 over 2 plus c. So because these are being multiplied, I don't need to use my distributive property unless I'm distributing the 6 to the constant, but that would only give me another constant. 6 times any number is just another number, which is what a constant is. So I've got 6 divided by negative 3. Well, that's going to eliminate the negative 3, and I'm going to be left with 2. So 2 times 2 is 4, and then 4 times 1. We got 4 here, and then we're going to go across. So we got 4 over x to the 3 over 2 plus c, 3 over 2. And now we can reduce this 3 over 2. We can reduce it by bringing it to 4 over x square roots of x plus c. Wonderful. Let's go on to number 6. We have got the integral of x dx plus the integral of 3 dx. Well, they're just two integrals, and I can take each integral separately and then just add the result. So the integral of x dx, I'm going to add 1 to the exponent. There's an imaginary 1 there, so plus 1. So I've got x squared over 2 plus x, 3x. And then we're going to say plus c, because that's the proper thing to do. And we're done. 7. We've got the integral of x to the negative 1/2. Well, that's nice. Whoever made this test already put it to the negative 1/2 power, so we don't have to do the algebra ourselves. What a guy. Let's see, we've got to take the integral here. Obviously. My mind fell asleep for a second. What we can do is we can use the addition property, which, this obviously subtraction. What we can do is we can break up this integral into two smaller integrals. So the integral of x to the negative 1/2 dx minus the integral of 16x dx. And we can evaluate these separately. And so we will. So the integral of x to the negative 1/2 power, well, we've done this plenty of times so far in this video. We've got 2x to the 1/2 power, or 2 square roots of x. And then evaluating this integral, we've got 16x, so we're going to add 1 to the exponent, which would make it squared, and divide by 2, so that'd be 8x squared, and minus. So our final answer, of course, plus c, final answer should be 2 square roots of x minus 8x squared plus c, because we can indeed evaluate the integrals separately. Number 8. We've got the integral of 1 over r to the 4th minus 5 over the square root of r plus 3 r to the negative 7 dr. We're going to use the same technique we used last time to break up the integral. So we wind up with the integral of, I'm going to pull up my exponents now, of r to the negative 4 dr minus 5, and I'm going to factor out that 5 r to the negative 1 half plus dr, the integral of, we're going to factor out that 3 r to the negative 7 dr. Awesome. So taking these, it should be really simple. It's just the power rule. We add 1, so we've got negative, well, we're going to divide by. So we've got 1 over 3 negative r to the negative 3rd minus, we got 5, let's use that bracket to signify that it's a multiple. We add 1, so we wind up with 1 half, so we got 2 square roots of r, and then we've got plus, let's do that, 3 bracket, we add 1, that'll give us 6, so that'll be 1 over 6 negative r to the negative 6 plus c. Alright, let's round this out. Let's bring this negative exponent into a denominator, into the denominator. So we've got negative 1 over 3 r to the 3rd minus, that's going to be 10 square roots of r, and then we've got 3 times 1 is 3, divided by 6 is going to be 1 half, so we've got negative 1 half, and this r needs to go into the denominator, so we've got r to the 6th, because it's a negative exponent, plus c. Awesome. That's a 10, not a 16. Alright, we're moving on forward. Let's go to number 9. We've got the integral of 4x to the 4th minus 8 over 2x to the 4th dx. Here, it looks like it could be long enough to attempt to use substitution, but that's not going to work. But what we can do is break up the numerator. Let me show you what I mean by that. We can break up the numerator into the integral of 4x to the 4th divided by 2x to the 4th minus, dx, minus the integral of 8 over 2x to the 4th dx. What I did was I split the numerator, and that's legal so long as I keep the denominator the same for both of them. Now it's a fairly easy integral. So we've got, actually let's cancel. We can cancel some stuff. Our x's cancel, and 4 divided by 2, well, that just goes to 2. And we don't have any x's to cancel, but we can definitely divide out 8 and 2 to get 4. Awesome. So we've got the integral of 2 dx minus, let's bring this up during this step, minus the integral of 4x to the negative 4th dx. So we've got our answer being 2x minus, we've got plus 1, so that's going to be divide by negative 3. So we've got 4 over negative 3 x to the negative 3 plus c, or 2x plus 4 over 3x to the third plus c. That's how I'd leave my answer. Alright, the last problem for this video, I'm going to break it up. I thought about that while I was beginning. So we've got number 10, the integral of 5x plus 4 over the third root of x dx. Okay. I'm going to do the same technique, probably a technique you're going to need to know for your test. We're going to need to break up the numerator. So we wind up with the integral of 5x over the third root of x plus the integral of 4 over the third root of x. Of course, both dx. Can't forget that. Now, it'll be more visual if we change this radical to exponential form first. So let's go ahead and do that. We've got the integral. Let's move that 5 on out. That'll be easier. Let's move that 4 on out. So we've got 5 now, and we've got x left, divided by x to the 1/3 dx plus 4 integral of 1 over the third root, x to the 1/3, x to the 1/3 dx. Okay. When we divide like bases and their different exponents, what we do is we subtract the exponents. So this is x to the first, that's x to the 1/3. So if I've got 1 minus 1 over 3, well then I wind up with, I've got to get a common denominator, so I've got 1 over 1, so I've got 3 times on the numerator and denominator. So I've got 3 minus 1 over 3 equals 2 over 3. So my numerator is now going to be 2 over 3, and this is going to go away. 2 over 3. To the power of 2 over 3, excuse me. Okay, and in this step, let's pull up the x to the 1/3 to the numerator. So what we're left with is 5 integral x to the 2 over 3 dx plus 4 integral of x to the 1/3 negative dx. That's a power rule again. Plus 1, plus 1. I don't think you need me to show you how to add fractions, so we've got 5 over 3, and then when you divide by 5 over 3, that's the same as multiplying by 3 over 5, so 3 over 5 times x to the power of 5 over 3 plus 4. Negative 1 over 3 plus 1 is power of 2 over 3, so this is 2 over 3. So I have to divide by 2 over 3, divide by 2 over 3. Dividing by 2 over 3 is the same as multiplying by 3 over 2. So I'm going to multiply by 3 over 2, and I wind up with my x there, and to the power of 2 over 3, like we discovered prior, plus c. Okay. So this 5 is going to cancel with that 5. 5 and 5 cancel. And this 4 is going to cancel with that 2, leaving 2 on the outside. So I've got a 3x to the 5 over 3 plus, well, what is 2 times 3? That's 6. 6x to the 2 over 3 plus c. And we can reduce this a little bit more by putting it into radical form. And in this case, we're going to have to factor out an x squared from the third root. So we've got 3x, actually just an x, square roots of x squared plus, we've got 6, we've got this third root of x squared plus c. And in fact, we can even factor out we can factor out a 3 from both, and we can factor out a third root of x squared. So let's go ahead and do that. 3 third root of x squared. What's left is an x. So we've got x, and what's left is 6 divided by 3 is 2. So 2 plus C, finally, is our answer. Alright, that was the first 10 questions. I think that I will pick back up, well obviously I'll pick back up at number 11. I think I'm going to break it up into 3 videos. So, if you needed another question, well, go to the next video. This has been Terry the Tutor. Thank you.